how do we check this? This is basically, here's my function. I want to know if it's in the kernel. Remember, what does it mean to be in the kernel again? If you're in the kernel of something, what happens to you? It becomes 0, right? After you apply the transformation to it. So would it be safe to say that what I really want to do for this problem is take my transformation, my operator, my L right there, apply it to x e to the x, and just see if you get 0, right?
Yeah.
Okay, so how am I going to do that? I like to just kind of do this term by term. Remember, every single d is just derivative. So I have a minus 2 derivatives of this thing. I'm just going to write that. Let's just go back to simple notation. Double prime on the x e to the x. Okay? And then plus 2 times 1 derivative of x e to the x. Okay? And then minus, some people make a mistake on this and they just write minus 1. Don't forget the minus 1 is being multiplied by x e to the x also. So I have to subtract x e to the x here. Okay? And now you just have to make sure you get 0. So I have to take 2 derivatives of, maybe I'll come over here to do it. So x e to the x, let's take the first derivative. What is the first derivative of x e to the x?
E to the x plus x e to the x.
Say one more time.
E to the x plus x e to the x.
E to the x plus x e to the x. So it's the product rule, right? The derivative of x times e to the x plus x times the derivative of e to the x. Okay, great. So we get that. And now I have to take another derivative. So x e to the x double prime really just means I'm differentiating this one now. And the derivative of e to the x would be?
E to the x.
E to the x, good. And the derivative of x e to the x is just this thing again. Yeah. So I end up with 2 of the e to the x's and then another x e to the x on the end of that. And that's what's going in for the second derivative right here. So I'm just going to sub that in, 2e to the x plus x e to the x. Okay? Then plus 2 times 1 derivative of x e to the x, which is e to the x plus x e to the x. And then minus x e to the x. I almost consider this as almost like a freebie problem. I mean, as long as you do your derivatives correctly, this is not very difficult. You're just basically plugging in a function into this operator, just making sure it all cancels out. Okay? The 2e to the x's are canceling right there. And then, well, everything does cancel out. Here's